Alright, this video is going to be looking at continuing on with functions and looking at different representations of them, different ways that we see functions presented. So we've basically talked about how functions are basically the same thing as equations in a sense. We'll get into more of the differences later on. But the first thing I want to look at is what's called writing function rules. So you may want to take a minute and pause the video to write all of this down, but it's all going to be very key in helping you write function rules. So basically what's going to happen is they're going to give you a word problem, very short word problem. And all you need to do is just write exactly what it says. But you're going to transform the math words into symbols, and we've kind of done this already a few chapters ago, so we will be it should be just a review for you. Now, a couple words and what they mean. Okay, the first one, if you remember, the word is means equals. So anytime you see the word is in these sentences or phrases, you're going to replace it with an equal sign. The word of means multiply. Same thing, replace the word of with the multiplication symbol. This third one is one that gets confused a lot. Anytime you see the word less than or fewer than, they both mean to subtract, and you probably knew that. But what's going to happen is it's actually going to be written backwards from the way it is read in the problem. And we'll do an example with one of these here in just a minute so you can see exactly what I mean. And you may remember this from back when we did it earlier. Now, with functions, you see the words input and output a lot. So in these sentences, phrases, word problems, anytime you see the word output, that's going to be your y. And anytime you see the word input, that's going to be your x. Okay, so if you need to take a second and pause this to finish writing this down, you can do that before we move on to the examples. All right, so the first two examples, we're just simply going to write the function rule or write the equation that goes with it. So if you look at number 1, it says the output is 5 less than the input. So again, I'm going to write exactly what it says. So the output, remember, anytime we see the word output, that's our y. Is means equals. Now here's what I was talking about earlier with the words less than and fewer than. We have the word less than, which yes means we're going to subtract, but I said that it's going to be backwards from the way it's read. So instead of this saying 5 minus the input, you're actually going to flip that around and do the input minus 5. Okay, and keep in mind, anytime we see the word input, that's our x. So x minus 5. And there's our function rule. Okay, number 2, the output is the square of the input. Okay, so again, the output, that's y, is, again, means equals. The square, now anytime you square something, remember, that means your exponent is going to be 2. So we're going to have the input with an exponent of 2. So input is your x, and then we just raise that to the second power. And there's your function rule for that problem. Now the next thing we're going to look at is called evaluating a function. So they will be giving you the function rule or the equation, and they're going to tell you what x equals. And all you have to do is just plug whatever x equals into the equation and then solve it. And yes, it really is that simple. So on this example, it says, what is the value of y equals 2x plus 5? So this is our equation. This is our function rule. So what's the value of y when x equals 3. So they have flat out told us if x is 3, then what would you get as your answer? So all I have to do is take this 3 and substitute it in for the x, because that is what x equals. So we have 2 times x. Well, x was 3 plus 5. Well, 2 times 3 is 6, and 6 plus 5 is 11. So your answer for the value of y would be 11 when x is 3. Now, on to the different ways that you will see functions represented. 2 more ways that we're going to see it. We're going to look at them as tables, and we are going to look at them as graphs. Okay? Now, a function can be represented by what is called an input-output table. Now, we have already mentioned that input is your x, output is your y, so it's the same thing as an x-y table, and we've made a lot of those already, so you should be familiar with that. So we have an input-output table, or you can represent it with a graph. Okay, so the example that we have here is for the function y equals x plus 2. That's our function rule. So in our input-output table, remember I've told you this numerous times, for your input, for your x's, just choose whatever numbers you want. They chose to use 1, 2, and 3. And then you just plug each of those into the equation, and what you get as your answer goes in the y column. So if x is 1, when I plug that in, 1 plus 2 equals 3. So that's why they put a 3 right there. 2 plus 2 is 4. 3 plus 2 is 5. Now, what that has created, and they've made another column over here, is a column for the ordered pairs. And remember, it's always x, y, alphabetical order. So this ordered pair would be 1, 3. The second one would be 2, 4. The third one would be 3, 5. So here are your ordered pairs. Now that is showing the graph, or I'm sorry, the input-output table side of a function. You could also graph it, okay? And if you could do it a couple different ways. You can plot these 3 points that were created in your table, and that's what they've done right here. These are the dots they have plotted. Or you can skip the table altogether and just graph the equation, which is what we've been doing a lot of lately. So keep in mind, you always want your equation to be y equals mx plus b. That's the easiest way for you to graph it. So in this equation, we have y equals x plus 2. So your slope, the number in front of the x, well, there's nothing there, but you know technically there's a 1. So your slope is 1. Your y-intercept is 2. So what you could do is plot your y-intercept, plot that 2. Notice that falls on the line. And then you're going to use your slope, which is 1. Now we want that to be a fraction, 1 over 1. So from here you would rise 1, run 1. Notice I've also hit the line. Rise 1, run 1. So every time I do that, it's falling on the line that's already there. So either way, you could show it in an input-output table or a graph, or just having the equation. Those are different ways that you're going to see these functions presented. Now, we're going to look at an example of another function. We're going to complete the input-output table, and we're going to graph it. Okay, so take a second. You might want to sketch all of this out real quick before we get going. So if you need to pause the video, go ahead and do that. Excuse me. Now, your function rule is right here, y equals negative 2x plus 1. So in your input-output table, we have an input column. We have a column for the function rule, And that's basically where we're going to be showing the work for it. We have an output column, and then we finally have a column to write the ordered pair that's going to be plotted. So to start out, let's fill in the input column. And again, this is your X column. You can use whatever numbers you want. So I'll just use 0, 1, 2, and 3. For the function column, I'm just going to show that I am plugging each of these numbers in for X. So for this one, we have -2. This time X is 0 plus 1. This we would have -2 times 1 plus 1. -2 times 2 plus 1. And -2 times 3 plus 1. For my output column, this is what the numbers you're going to put here are basically what you get for your answer when you solve this. So -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 1 is -1. -2 times 2 is -4, plus 1 is -3. -2 times 3 is -6, plus 1 is -5. And you may have noticed a pattern there. It just goes down by 2 each time. And then the last thing we're going to do is write each of these as an ordered pair. So we're going to take the X and then the Y. So for this first one, it's going to be 0, 1, then 1, -1, 2, -3, and 3, -5. Okay, now I could go and plot all 4 of these points on my graph, connect them, and that would show the graph part of it. But what I want to do is I want to graph this equation as if I hadn't even made the XY table or the input-output table. So we need your slope and your y-intercept. So your slope, remember, is the number in front of the x, so -2. Now that would be -2 over 1. Your y-intercept is that other number. Since it says +1, it's going to be +1. So first, you plot your y-intercept. So put a dot at 1. That's where it crosses the y-axis. Then your slope tells you where to go from there. Rise over run. So I'm going to rise a -2. That means I go down 2. And you're going to run 1. And I could do that again. Rise a -2. Run 1. So here is your line. Make that as straight as I can. And what I want to show you is that every single one of these 4 points would fall on that line. So 0, 1, over 0, up 1, that's right there. 1, -1, right there. 2, -3, right there. And then 3, -5 would go off my graph, but it would fall on that line. So that just shows you that you can graph the equation using the slope and the y-intercept, or make an input-output table, and it would get you to the same graph. Now, you'll end up using both forms of this on your assignment, which is the worksheet that goes with this. So hopefully having this example with the input-output table and the graph will help be very helpful.